Let me welcome you to the lecture number 51 of NPTEL online certification course Underground Mining of Metalliferous Deposit. We are discussing about the different methods of excavation can be adopted in an underground mines of metalliferous deposits. And as we have classified, there is a classification artificially supported mining methods. In fact, if one kind of that artificially supported mining methods is resuing method of stopping, which can be adopted in the underground mining of metalliferous deposit. So, in this lecture we will discuss about this resuing method of stopping, but as we do every class, let us have a glimpse of the learning background required for the participant of the NPTEL online certification course Underground Mining of Metalliferous Deposit. These are the learning objectives of this course and expected learning outcomes from the participants who will undergo this course. These are here, and these are some of the text and reference books participant can follow apart from these lectures also. Apart from that, I will also ask about some of the internet sources, YouTube videos. There are plenty of good videos, animated videos are available for the method of mining, stopping methods, developmental works. Those are very good and noteworthy. These are the learning objectives of this lecture. As it is said, to understand the excavation related issues of narrow vein deposit and to understand the resuing method of mining. So, why we have placed this word narrow vein deposit? Because resuing method of mining is adaptable in the narrow vein deposit only. So, the problem in the narrow vein deposit has to be understood. So, this is one main objective in this excavation method. So, let us start with what is a narrow vein. Narrow vein means you can see if the vein size is very less, you can see this is the size of the vein or thickness of the vein, and that is why it is called narrow vein, and this size is not significant enough that a person can walk there very comfortably. So, you can see in this figure also, as this is also another narrow vein, you can see this is the narrow vein, and that is why a person is not stand enough and can carry out his drilling work, etc. So, where the space is not significant, the thickness of the deposit is less, that is called narrow vein, and generally narrow vein means it is not comfortable enough by principally. Sometimes often we consider it is less than 1 meter, sometimes we consider it is less than 2 meter is supposed to be the narrow vein, which is not thick enough for the deployment of the man and machine, that is considered as the narrow vein deposit. So, in this narrow vein, how the excavation has to be carried out, that is the problem in the underground metalliferous mining. So, first let us understand why we will try to excavate the narrow vein, because as the vein size is thickness is less, that means a not significant enough deposit is there, but the narrow vein generally practiced for mining where the ore is very valuable or the grade is very high, or the minerals say like gold. You can see this is the gold vein, this is also you have seen this is the gold vein. So, the mineral is precious. So, that is why people are interested to carry out mining there, and that is why the mining carried out there with slow pace, with great difficulties, also profitable. In that condition we go for mining of the narrow vein deposit. So, let us first discuss about the resuing method. Resuing method, also called resu method, This is first practiced in 1920 is Sub-Nigel gold mines of South Africa. You can see this is a gold mine. So, as there was a narrow vein, then also this method was developed for carrying out that excavation of the gold deposit in South Africa in late 1920s. And up to 1960s, n number of other South African mines adopted this resuing method of mining, and where this narrow vein of valuable ores, and this involves blasting of sizable quantity of barren wall rock in contact with the vein to achieve the desired dimension of the opening. So, this dimension of the opening, to achieve that, this additional excavation is carried out. Now, you can see in this picture the vein is up to this, but this additional excavation is carried out to have the desired space in the underground working. So, narrow vein deposit with valuable ores, resuing method can be a suitable method. Now, let us understand what is resuing method. Consider this is the narrow vein, and this narrow vein comprising valuable ore, and while we are excavating this narrow vein, we are also subsequently excavating this additional wall rock. Now, in this case you can see this wall rock is hang wall we are excavating, but alternately you can excavate the foot wall also, and whether you will excavate the wall rock hang wall or foot wall, this decision depends on your type of wall rock, how much strong it is, which one is preferred, what is the method, what level of dilution you can expect. In that consideration you can carry out this excavation. Now, here importance is that if you are excavating the foot wall rock instead of hang wall rock, then your ore face will be little bit ahead of the foot wall rock. If you are excavating the hang wall rock, your hang wall rock face is little bit in advance with the ore body. So, that is why this is there are basically two faces, one face in the wall rock, one face in the ore body is moving simultaneously, and they are having a little bit of distance lag. So, you can say the wall rock face in this case, or whichever is in the hang wall side, that face is little bit ahead of the other one. So, basically vein of high grade ore having a barren wall rock is in the high wall, and both are excavated. This high wall, whatever is excavated, is used for filling of the stope, and that is why transportation cost is not a significant problem for additional excavation of the hang wall. So, broken rock of barren wall is used as the filling, which we have already told, and valuable veins so exposed are then blasted down and allowed to fall through the chute, and which are usually placed at an interval of 5 to 10 meter. Now, here if you are looking at this, so whatever is the valuable mineral, so as we have blasted down this one, so the material is allowed to fall on this, we provide a chute at this position, and that chute is basically taking the material and placing it into the lower level. Now, as this is in this case basically we carry out blasting. We carry out blasting maybe on benching method, or mostly as it is already exposed, we go for benching method of blasting for the lower one, or we can go for the similar way we carry out blasting here, it is a burn cut or the stove blasting. The same way we can carry here also, but benching method of blasting is preferred. The blasted rock mass is basically guided to the chute. Chute is provided. So, chute is provided here, and this is guided to the chute. Some are automatically falling into this, some are basically guided or pushed using some manual labor or with small machines can be carried out, because the operation of the machine is now allowed with this dimension. So, this is, if this is very narrow, a little bit of additional one is excavated. So, that is why the sufficient dimension for the machine movement is created in this particular case. So, this is the resuing method which is applicable for the valuable ore and for the narrow vein deposits. This method is applicable. So, mostly so far it is found in the gold ore only. Now, let us look into the developmental work. You understand our developmental work comprises of first the construction of the shaft, then we enter into the levels through the shaft, and then from the shaft we entered we make the cross cut to connect the ore body, and the methods adopted for these are the applicable methods. These are the auxiliary operations to be carried out while the construction of cross cut or haulage roadways are made. Then we go for excavation of cross cut, and then we go for construction of the haulage drifts, and then cross cuts between the drifts and the ore body. Often we do not go for construction of the drift, we directly use the go for construction of the drive edges in the ore body itself. Then from the ore body we keep a sill pillar, and then we directly enter into the stope. So, if we look into the sections, if this is our total excavation zone, this is our ore body, and if you are considering this is our lower level, these are the ore chutes, these are the ore chutes made. This is the hang wall rock, and this is a sill pillar is kept here. This is the sill pillar kept at this position as the support, and this blasted rock mass is of hang wall is allowed to act as the filling material on which the machine can stand, and this ore material is allowed to guide it in the rope, and eventually it is taken from the lower level. So, this lower level drive, instead of haulage drive, we make a drive in the ore body itself, ore drive is made, then the ore drive is considered as the haulage drift, and from there the material is taken. and similarly in the upper level side, we keep a crown pillar. This crown pillar which is kept here will act as the support for the haulage drive. So, this is the method which is adopted in the surface in the resuing method, and these are the raises and winges used to enter into the stove. So, this is the description of the method. You can see which we have already discussed here. Here the mining is carried out in the footwall instead of hang wall. This is the reef, reef means vein. So, this is the vein and this is the mining is carried out in the waist also, and you can see this face is advanced, hang wall face is advanced than the footwall face. So, that is why here reef is working in advance and wall rock is moving behind the vein face. So, the decision whether the footwall has to be excavated or whether the hang wall has to be excavated is the both the way you can carry out resuing mining. Resuing mining means you are additionally excavating some hang wall or footwall rock for having some additional width in which your operation can be easier. So, you can describe it that initial slice is taken after the sill pillar from the raise. The first slice is driven manually through the waste rock first and then for the reef vein separately. The valuable ore is taken out through the ore chute. After the first slice sequence, slices are taken, the slices in the waste rock runs ahead of the ore face. The method of mining is drilling and blasting. Blasted waste rock is left in the stove which will act as the packing. This poses a risk of dilution of the ore, but as the ore grade is sufficiently high, this dilution can be accepted in the overall level. So, there is a little bit dilution, that is a disadvantage of this method. These are the practices burn cut. These are the different cost analysis. As it is a South African case study, you can see it is given in rand per ton. And this is applicability, a well defined plane of weakness such as the clay seam or one side of it should be there in the one side of the vein. Vein is preferably steep, vein is valuable enough to pay for unprofitable blasting carried out for the waste rocks and also for the dilution also. These are the advantages, the high grade ore which is not mineable, that is being excavated and taken. These are some of the advantages given. These are the disadvantages where dilution is a very big problem, excessive waste handling, that is another problem. These are the resuing method problems associated with the advantages, disadvantages. Now, let us once look into the new method in which the vein is excavated through drilling only. Narrow veins are excavated using large dia drilling only. The similar way you have seen the drilling is carried out in the raise borer or winch borer. The same type of drilling is adopted here. You can see this is narrow vein excavation using large dia drilling. So, this is the narrow vein. You can see the thickness, this is the strike length, you can see the thickness is limited. So, if you are looking at this, these are the different levels. Now, you can see how the thickness is very less, and this is the ore body, strike of the ore body, and it is decided that this will be excavated using the drilling only. So, that is why this large dia drilling, which is the diameter of the drilling is suiting the thickness of the deposit. Now, the drill, you can see the drill machine is angling the deep angle of the deposit. Now, the drill is placed and it is decided the drilling will be carried out and the drill cuttings will be collected as the outcome of the mine. So, you can see this is a small width ore, small thickness ore. So, the system is more or less similar with the raise boring system. You can see this diameter is similar to the thickness of the deposit. Now, it is drilling is started. See, now drilling is started. This is the drill cuttings collector. So, the complete drill cuttings will be collected here. This is the inclusion of the additional drill rods, you can say. So, this is the complete drill assembly. So, now this is the collector. As the drilling is carrying on, so drill cuttings are collected, which is a valuable mineral. So, this is collected. Now, first rod is drilled, now the second rod has to be inserted there. So, like this drilling is gradually carried out and the drill cuttings are collected here and it is taken out as the output of the mine. This may be a mine cart, this may be any box which is used. This can be matched with the chain conveyor also. So, you can see these are the holders which is holding the drill rod and the additional drill rods are. You see how the material is moved. So, material is guided through this and finally, it is discharging at this. So, this is the material movement. So, this material is basically drill cuttings which are the valuable minerals. And like this way the complete excavation will be . So, this excavation is carried out completely and after that the drill cuttings are taken as the ore and it is removed. Now, you are gradually taking out one by one the drill rods. So, these drill rods are now being removed gradually one by one. So, one by one drill rods are being removed now. So, now the complete drilling is taken. You can see like this way one by one drilling is carried out, leaving a small part between this and these pillars are rib pillars are left like this, but this rib pillar can be removed also. The complete which excavated portion can be sealed with a filling material, compost filling material which can act as the supporting rib pillar, and by providing this artificial support Now, these rib pillars are also becoming recoverable. So, the complete excavation, more percentage of excavation can be carried out as the mineral is very valuable. So, it can be possible that the rib pillars can also be removed at a later stage. See, the machine is coming again to carry out drilling to excavate the rib pillars. So, initially leaving some rib pillars which is of equal length of the diameter of the drilling, the material was excavated. Now, the second slot, the rib pillars will be recovered, and along with that the rib pillars portion will be again finally sealed. So, like this way almost close to 100% excavation can be carried out of the valuable minerals using this large dia drilling cum excavation system. So, this is more or less about the excavation of the narrow vein deposit. We have seen resuing method as well as the drilling methods are available for excavating these deposits. This all from this excavation of the excavation by resuing method. Thank you.